Assalamualaikum and hi everyone. Okay, today we're going to chapter 4, and chapter 4 will deal with the compressed air system and also pneumatic system. Okay, so we will look into this topic, and for the first part we are looking at the basic pneumatic system and its application, and also we look at the basic component in the pneumatic system. Okay, pneumatic related to automation, in which they replace the human task to machine. And usually it will pneumatic system used widely in the manufacturing, in which to optimize productivity. Okay, by having pneumatic system, it will increase or double up the productivity, and all the activity in the factory will be done in a very efficient and effective way. And pneumatic is using a pressurized gas to enable mechanical motion. So these are some of the pneumatic system. Okay. And what is pneumatic system? And we know that in the manufacturing industrial robots, okay, they are dealing with the pneumatic system and also the conveyor belt. And pneumatic components can perform lots of motion, linear, swivel, rotary, and these are the example of the pneumatic system applied in the industry. Okay, these are the advantages on the compressed air. Why it is better to use compressed air. In terms of availability, okay, air is everywhere, and transport is easy. Okay, storage, it can be stored in the reservoir or in the tank. And then temperature, okay, they are not really sensitive to temperature and can be used even in the extreme condition. And then explosion proof, in which minimal risk of explosion or fire because they deal with the air. Okay, and in terms of cleanliness, yeah, the air is very clean, and when we exhaust the air from the system, it can release straight to the environment. And then the component simplicity of the design, okay, relatively not expensive and available anywhere, and adjustable, okay, easy to control the speed and the force, and overload safe, in which it can to the point of stopping, means that we can set or we can program so that it will not exceed some of the limits. Yeah, and then on the speed also, it can go for high working speed. Okay, these are the advantage of the compressed air. Okay, and then one of it is proper preparation. Since we use the normal air, so sometimes the air have humid, and also sometimes there's dirt or condensate when you intake the air to the system. So you need to proper treatment or proper preparation before you compress the air. And then not uniform compressible. Okay, sometimes not always possible that you can achieve uniform or constant piston speed with compressed air. It's a bit tricky to control it. And limited force requirement. Okay, economically up to certain force, and if you want to go for more force, bigger force, you need to use hydraulic. And noise level, okay, exhaust air, when you release the air from the system, it's gonna give you a loud noise. Okay, but it can be solved for the noise by using silencer. And cost, it means cost in terms of conveying power. Okay, so if you want a high performance, so you need to have like, even the component is not expensive, but the process of compressing the air to have the big force will cost more. Okay. Alright, let's go to the pneumatic component. So usually they are using the normal atmospheric air, okay, as an intake air, but you need to remove the moisture, okay, and small quantity of oil is added to the compressor. So compressor is the main component in which you will use to compress the air. And why you need a small quantity of oil is to prevent corrosion and also lubricate the mechanical component. Okay, these are the basic component. Okay, this part is for the air production. And then this is the filter, regulator, lubricator, and these are the part that moving in which they are using in the actuator. Okay, before going to actuator, they will firstly go into the DCV, in which directional control valve. Okay, in the industry, usually they have a system. Okay, it's like a piping system, and which they have a compressor. Okay, and then they use the piping to supply the compressed air throughout the layout. Okay, and these are the basic components that you need to know. Compressor. Okay, the function of compressor is to pressurize the air. And then we have directional valve, in which to control pressurized airflow from accumulator. Okay, accumulator, in which they store the compressed air from the compressor, and it will control or prevent surge if there's a changes in pressure before they go into the directional valve. Okay, and from the directional valve we go to actuator. Actuator function as a converting the energy stored in the compressor into mechanical motion. So you can design and have a combination of actuator to do the activity in the factory. And then check valve is used for the system in which we have one-way valve to allow pressure air to enter but to prevent backflow. Okay, so these are the basic components. And we start with the air supply system. Okay, so we need a air service unit to make sure that when the air is received from the compressor, they need to have the air service unit, and this is the symbol. And during the design of pneumatic circuit, we will use this symbol. Okay, let's look the video on compressor.
Air compressor is used to produce the compressed air for the system. It is a device that converts power into potential energy and stores as pressurized air. There are several methods for a compressor to convert power into potential energy. An air compressor forces more and more air into a storage tank, increasing the pressure of the storage tank to required pre-specified pressure. When the tank's pressure reaches its upper limit, the air compressor shuts off. The compressed air is held in the tank until called into use. The air pressure contained in the air storage tank can be used for a variety of applications, utilizing the kinetic energy of the air as it is released and the tank depressurizes. When tank pressure reaches its lower limit, the air compressor turns on again and repressurizes the tank.
Okay, next we're going to valve. Valve can be divided into numbers of groups. Okay, but the main function of valve is to alter, generate, or cancel signal. Okay, so for purpose of sensing and processing and control, valve is the main component in which used to control all the compressed air. The first one that you need to know is the DCV, Directional Control Valve. It's for signaling, processing, and power. And there's also non-return valve, flow control valve, pressure control valve, and combinational valve. So DCV is the main valve in terms of having to control the movement of actuator.
Valves are used to control flow direction of the compressed air. It is a device that regulates, directs, or controls the flow of a fluid by opening, closing, or partially obstructing various passageways. Valves are technically fittings, but are usually discussed as a separate category. In an open valve, fluid flows in a direction from higher pressure to lower pressure. The valve is simply a freely hinged flap which drops to obstruct fluid, gas or liquid, flow in one direction, but is pushed open by flow in the opposite direction. This is called a check valve, as it prevents or checks the flow in one direction. Modern control valves may regulate pressure or flow downstream and operate on sophisticated automation systems. For a circuit.
Okay. So in the directional valve, it controls the motion and also start and stop the flow, okay, of the compressed air, and also it used as a limit valve. So these are the name of the DCV: 2 ways, 3 ways, 4 ways, okay, the position, and then the method, and also the valve need to return. Sometimes they use the spring and sometimes they use the air. Okay, for signal element, okay, these are the limit switch in which to detect the piston rod position of a cylinder. So we will use this in our circuit. And non-return valve usually for signal to flow through the device in one-way direction. Okay, they will help to regulate the compressed air. And then these are the flow control valve. Okay, and to reduce the flow rate, is control the flow rate of the compressed air. And pressure control valve usually used for regulating, limiting, and sequence. So it's a combination of control valve involved in the pneumatic circuit. Okay, these are the pressure sequence valve. Okay, and these are the combination valve. And they also have a logic element in which sometimes you need to use it in the design of the pneumatic circuit with the AND function, okay, or the OR function. The AND function is known as the two pressure valve, and this one is the AND function, and the other one is the shutter valve, or for the OR function. And these are the one that we use, okay, to convert the compressed air into mechanical action. So it transfers the quantity of air into the actuator. So actuator can be linear actuator or rotary. Rotary means that it moves in the round motion, okay, circular motion. And linear is usually like this kind of actuator. Okay, let's look into the actuator.
Pneumatic actuators enable considerable forces to be produced from relatively small pressure changes. A pneumatic actuator converts energy formed by vacuum or compressed air at high pressure into either linear or rotary motion. Pneumatic energy is desirable for main engine controls because it can quickly respond in starting and stopping, as the power source does not need to be stored in reserve for operation. Moreover, pneumatic actuators are safer, cheaper, and often more reliable and powerful than other actuators. These forces are often used with valves to move diaphragms to affect the flow of air through the valve.
Okay, so these are the symbol, okay, that we'll use in the pneumatic circuit. Okay, these are the complete simple basic component in which we start with the motor linked to the compressor. Okay, and then this the accumulator, and this the air service unit, and then we have the DCV, directional control valve, and then we have the flow control valve, and at the end we have the linear actuator or the rotary actuator. Okay, so we can see that these are the part for supplying. Okay, these are the service equipment in which they have to clean the air, remove the condensate, and this one is the part where you do the control of the compressed air, and then we have the valve control here, flow. Okay, and at the end it will translate the compressed air into mechanical movement. Okay, these are the common symbol. So usually in pneumatic circuit we use the simple one in which these two, we will see this a lot. Okay, this one is the pressure source, and this one is the air service unit. And for the control valve, okay, these are the port, you can read in the notes. And usually we involve with this one. Okay, so not all that we're going to use for our pneumatic circuit. Okay, this one is the common one, we will use this one. And for actuator, we will use this one, double acting cylinder. And for the push button, we're gonna use this a lot. And also it should be spring return type of actuator, type of switch. And we have also roller operated switch. And these are some of the symbol, but we are not using it. And for the check valve also, not all that will be involved in our design of pneumatic. Okay, these are the flow control valve, and these are the process. Okay, so we start with the energy supply, and then input signal, processor signal, and at the end where we translate the compressed air into mechanical action. Okay, these are the detail. We start from the air or energy supply here, and then the sensor here, DCV, and then we have the logic element, and then finally just before entering the actuator we have another DCV. Okay, these are some of the questions that related to the advantages and disadvantages, and also the function of component that used in the compressed air system. So we will discuss this in the live session. Okay, I see you in the live session. Bye.